section 5.2 is on adding and subtracting polynomials, which truthfully really just amounts to combining like terms in a lot of ways. So it's kind of a review. There's a little bit of vocabulary here at the beginning that we do want to make sure that we can use properly and identify some things. So let's start with that. So poly, that prefix stands for many. So we have many terms. And when we think about a term is going to be constants, variables, exponents. Basically, when it's all multiplied together, that's going to be a term. So any number of terms, then that's going to give you a poly, many terms, essentially. So we'll talk about binomials. Those will just be bi prefix 2 terms, trinomials, the tri prefix 3 terms. After that, we tend just to go to the poly prefix. And so when we're talking about polynomials, we are talking about variable terms with exponents, with whole numbers in those exponents. Okay, degree of the term is often just the power of the variable, but if there's more than one variable in that term, we'll say it's the sum of the exponents. The degree of a polynomial is the highest degree of any one term, and the leading coefficient is the coefficient or the number in front of the term of highest degree. So let's start with what I would call the more basic, which is when you just have one variable in your polynomial. More basic and more common, probably, for what we're going to look at. So I'm deliberately writing this example in a non-traditional order. Like most of the time we write things in what we call decreasing order of exponents. So typically you would start with like the x to the 4th term. But I've deliberately written it in a different order so we're paying close attention to some things as we go through here. So we have 6x minus 3x to the 4th plus 5x squared minus 4. So what we want to do on these is we're going to identify a little bit of everything. So I want us to define or identify the degree of each term as we go through here. So the degree of each term. And then I want us to answer what would be the overall degree of the polynomial. So then what will be the degree of, as we would call it, the entire polynomial. And then I want us to identify, even though I didn't put that in the directions, I do want us to identify, I just accidentally left that off, the leading coefficients. All right, so the degree of each term is just going to be when it's one variable, this is going to be kind of easy. It's just the power of the variable in that term. So this is an implied x to the 1st, so the first term is 1, x to the 4th, so this is going to be a degree of 4. Next one is x to the 2nd, so degree of that term is 2. The last one might be kind of intuitive. If there's no x, like a degree 1 term is x to the 1st. If there's no x, it's x to the 0. You could also think of it as being an x to the 0 term, because anything to the 0 power is equal to 1. So negative 4 times 1 would be equal to negative 4. So you could kind of think of that last term that way if you wanted to. So there's the degree of each individual term. So that means the overall degree of the polynomial is going to be whatever the individual term of highest degree is. So the degree of the polynomial here would be 4. And then the leading coefficient is the number in front of that term of highest degree. So we call it leading because a lot of times it'll be written first. So it'll kind of lead the polynomial. But I deliberately wrote it in a different order, so we're kind of paying attention to that. So the leading coefficient here would be negative 3. Okay, so let's look at another example, just one more. And so on this one, suppose we had maybe 3x to the 4th minus 2x cubed y squared, and then plus 4xy cubed, let's say. I don't know. All right, so as we look at something like this, Again, we're going to go through and identify all the same things that we did up above. So I want us to figure out the degree of each term, and then we'll look at, kind of based on that, then what would be the degree of the entire polynomial, and then I want us to finally identify what the leading coefficient is. So then we'll end with our leading coefficient. So these are the ones I think are a little trickier when there's more than one variable. Okay, so the first term though, just one variable, and so the power on that variable is a 4, so the first term has a degree 4. The second term though, there are two variables, and what the definition up above says is that we take the sum of those. So we add those up in order to get the degree of that second term as 5. And then same thing on the degree of the last term. We are going to add up the 1 and the 3 to say the degree of the last term would be 4. All right, so with that, that's the hardest part. Then the degree of the polynomial is, of course, 5, because that's the highest degree of any one individual term. And then the coefficient in front of that highest degree term in this case is -2, so that is our leading coefficient. All right, so that's some of the vocabulary that we want to make sure that we're familiar with. Okay, now we're going to just move into some examples where, again, I think you're going to find a lot of this section to feel a lot like a review as we look at some of these examples. All right, so the first one I have is an evaluate problem. We've been evaluating since the first chapter. So let's evaluate the polynomial -x squared minus 4x plus 3. So I would call that polynomial in particular a trinomial. It has 3 terms. The degree of this trinomial of the whole thing would be 2, because that's the highest degree that we see, the highest power of the variable. And the leading coefficient on that would be the -1, because that's the coefficient in front of the x squared term. All right, in this case though, we're just evaluating and we are just subbing in the 3 in implied parentheses every place where we have an x. So that's of particular importance to focus on in that first term, because we need to recognize that it is only the 2 that is applied, or the 2 only applies, to the 3. So that negative was never part of the squaring on that first term. So this is -9. And then the second term, we have a little multiplication we can take care of there, -12, and then plus 5. So adding up, taking the sum on those two negatives, we get -21 plus the 5. And then different signs, take our difference, and that would be -16. All right, let's look at some simplifying of polynomials here, and I'm going to throw in some fractions just because it's always good to review fractions. All right, -1/2 quantity x squared minus 4x plus 1 minus the quantity of x squared plus 3x minus 5. Again, this should all feel real familiar. So we have two trinomials, a combination of them, 1/2 times the first minus the second. But we treat this really just like any simplified problem that we have from this whole class. We start by distributing any of the numbers directly in front of the parentheses, including in the second set here, the implied -1 that we are distributing. So in the first term of the first set of parentheses, that's just our -1/2 squared. And then in the second term, negative times negative is positive. Hopefully you feel pretty comfortable with multiplying the 1/2 times the 4/1, and that just gives you the 4/2, which is 2. So this is going to be 2x, and then minus the 1/2. And then distributing through the negative in that second set of parentheses. So -x squared, minus on the 3x as well, and then careful with the two negatives, the last term changes to addition. Now we have to combine some like terms. Well, there's nothing to combine with the negative x squared. Yes, there is. I lost my square. Careful, careful, careful on my first term. So I do have two x squared terms that I can and will combine here. So I have a negative x squared and a minus 1, a minus x squared. So that's like this implied negative 1 that's sitting here. So we are adding up two negatives, so we really are taking the sum. We have negative 1/2 minus 1. So for me, I like this idea of just thinking about adding up two negatives. I take the sum. 1 plus 1/2 is literally the definition of negative 1/2. Excuse me. But typically we like these as improper fractions. So we would take that as negative 3/2 as the coefficient of the x squared. You could also rewrite the 1 as a 2/2, and you could make a common denominator out of that. So you could have also thought of this as negative 1/2 minus 2/2, and then that takes you to the negative 3/2. So either way, negative 3/2 x squared. All right, then we move on and we do have some x to the first power terms to combine there. So on that one, we're going to have a positive 2x, so plus 2, and then the minus 3. So 2 minus 3 there is going to give us our negative 1, or just negative x. And then our last step, we do have a couple of plain old numbers here, a minus 1/2 and a plus 5. So as we think about that, again, I would just think of it this way. I would think of it kind of from an intuitive standpoint. 5 minus 1/2 puts me at 4.5. And then I like the idea of just going to the improper fraction. 4 times 2 is 8, plus 1 would be 9/2. Or again, if you prefer, you could think of that as 5/1 and multiply by 2/2 and make that 10/2 minus 1/2, and then that gets you to the 9/2. So I think that's kind of up to you. I think sometimes just going to that intuitive idea of 4.5 and then take that to an improper fraction, to me, that's a little easier. But you should know how to work with fractions. All right, that was part A. So again, review, right? We're just combining like terms. Hey, let's look at just one more here. So suppose I have 2x squared y plus 4xy minus x squared y squared. So polynomials, many terms here being added or subtracted where the powers on the variables are just nice whole numbers here. Positive whole, well, whole numbers are positive. So minus the quantity of x squared y minus 7x squared y squared. Okay, so this one's a little different than part A, just in the fact that we have xy's in all of our terms here. So in the first set of parentheses, there is nothing to distribute. There's nothing in front of that first set of parentheses. So I'm just going to rewrite those three terms. In the second set of parentheses, I do have this minus 1 to distribute to those two terms. So minus x squared y, and then careful, plus, because of the two minus signs there, 7x squared y squared. Now here's something that I think students sometimes will do, so don't write this down, but there's something about as they're just writing their own work and they start to almost look at that space that gets created, and sometimes it's in typeset as well. Like there's a visual space sometimes that even looks more significant than what I wrote. That's really just room for us to write or for a computer to type an exponent. And it starts to almost visually do something to students where they think of them as two different terms, and they're not. This is all multiplication, that's one term. This is not a 2x squared and like a plus xy. Okay, right? So when it's all multiplication, no matter how visual it looks spaced out, I mean, even if I wrote it like this, those aren't two separate terms. If there's nothing in between, that implies it's all multiplication. So my point is here these terms are separated by the adding and subtracting. So right now we have a total of 5 terms altogether here. So let's look for our like terms. So the first thing we want to take a look at, I'll just use my first term that I come across, which is an x squared y term. So I'm looking for other terms that are exactly x squared and y to the first power. And so I have one other x squared y term. So we have a 2x squared y minus an implied 1x squared y. So the 2 minus 1 is an implied 1. You don't need to write it, but you can. And remember, when we add and subtract, we don't change the variables. They're kind of just like labels. So x squared y. So this is going back to the big idea that I talk about, that in algebra we can add and subtract like things with like things. So my next term I see is a 4xy. I don't have any other x to the first power y to the first power terms, so I'm just going to rewrite that one. The next term that I come across here is an x squared y squared term. And notice how every time we're always looking at the sign in front along with that coefficient. So this time I do have another x squared y squared term. So I have an implied minus 1 x squared y squared and a plus 7 x squared y squared. So 7 minus 1 gives us that 6 x squared y squared. Okay, so that's our final answer. And again, you could reorder these terms in some other order if you wanted to, but I'll just go ahead and just leave it just like that. All right, so when we come back next time, we're going to end this video here. We're going to look at some, some perimeter and areas that involve some algebraic expressions on those, and just kind of look at a variety of other problems that will involve some of these adding and subtracting of polynomials. So we'll take a look at that next time.